For more than 50 years, innovation has been at the heart of Intel. From campuses to hospitals, battlefields to the stars above, we are trusted by our partners to meet their mission challenges head-on, accomplish their goals, and improve lives across the globe. Guided by ubiquitous computing, pervasive connectivity, cloud-to-edge infrastructure, AI and sensing, we ensure our partners are capitalizing on the full power of digital technology to drive mission success. With a commitment to US-based manufacturing, we are on the forefront of cutting-edge solutions that lead to a more responsible, inclusive, sustainable, and technology-enabled world. Achieve your mission faster, more efficiently, and more securely with Intel.
What a great morning we've had so far, everyone. My name is Nicole Smith, and I serve as the Executive Director of AI Consulting at Mantech. Mantech has been a long-standing in-support member, and we sincerely appreciate their commitment to public-private partnerships exemplified by today's discussion. These programs are crucial for exchanging ideas, insights, and best practices in support of our shared national security mission. Mantech has been providing mission-focused technology solutions and services for more than 55 years. We are a leading provider of AI solutions that power full-spectrum cyber and data collection and analytics in support of our national and homeland security. Now, it is my pleasure to introduce the moderator of our Ignite rounds, Bishop Garrison, who serves as INSA's Vice President for Policy. With over 20 years of experience, Bishop is a seasoned national security executive, veteran, and writer. His extensive background includes service in military, presidential administrations, and campaigns, nonprofits, and the private sector. In his previous role for Vice President for Government Affairs and Public Policy at Paravision AI, Bishop advocated for thoughtful and ethical policy regarding the deployment of computer vision AI products. He also served in the Biden administration in the Senior Executive Service and as a senior advisor to the Secretary of Defense for Human Capital and DEI. Please join me in welcoming Bishop Garrison to the stage.
Thank you so much, Nicole. I greatly appreciate that. And thank all of you for joining us. We have an incredible lineup of Ignite Round speakers ready to share their perspectives on the future of AI and human-machine teaming. To kick things off, I ask that you please welcome to the stage Rachael Martin, Director of NGA's Maven project, who will address human and machine testing and evaluation. Rachael.
Good morning, everyone, and thank you for having me. Human and machine teaming can mean many different things to many people. I think it's become almost a cliche at some point when we talk about the importance of human and machine teaming. But so I wanted to talk a little bit about what we mean when we say human-machine teaming at Maven. We think of our human and machine teaming in two ways. We think about it in terms of how is our AI improving the work that humans do, and how are humans reacting to the outputs of an AI system. In both cases, we've adopted a quantitative approach to measuring what changes and what occurs when you begin introducing AI into the mix. And we call this our human-machine test and evaluation. Before I get into the details of exactly how we do this, I do want to briefly touch on why this is important. I think first and foremost, understanding the interactions of human and machines is core to the principles of responsible and ethical AI. Part of a well-functioning human-machine team is a human that firmly understands the limits of the AI system and firmly understands the limits and dangers of an AI system, both from a technical level, is it trained correctly, and also from a user perspective, is it being used in the way that it was intended? And the second reason it's important to have a quantitative approach to our human and machine tests and evaluation is, frankly, we all think that Uncle Sam's pockets are limitless, but across DoD and IC, programs across the board are being pressured to find efficiencies. When we think strategically about how users engage with our AI products, we can make the most effective decisions and make the most of the resources that we've been given. Human and machine T&E lets us make informed decisions on where we can best optimize our investments, and do so with quantitative data and a firm understanding of our end users' activity and their requirements. And, spoiler alert, these are not always the same thing. So I'm going to start by talking about how we measure the improvements that result from an effective human-machine team. The first step in understanding how an AI can improve the work that humans do is to first understand who your user is. Maven relies on a network of military LNOs at the combatant commands and military services. These individuals are our first line of engagement with our operational customers. We believe that we need to be where our users are, and ideally our military LNOs will be part of the warfighting community that they represent. We also routinely and regularly engage with representatives from our core user groups and use a forum to both provide updates on our efforts, but also hear back from them on where we could do more, where we could do better, or where we could just stop doing something altogether. In order to ensure we're building with our customers, our operational end users begin using our AI capabilities as soon as we have that minimal viable product. And sometimes they're even working with us to deliver that MVP. And the feedback loop that we build there continues throughout the entirety of the development cycle. Once we've established a new AI product, we begin to work to measure and understand how that capability is changing the way humans do work. And here's an example. One of our product lines is AI-enabled workflows. As more sensors and sources of collection are proliferated, it stands to reason that the volume of data that needs to be processed and analyzed has grown exponentially. And this is at odds with many legacy workflows, which may have been effective when those data streams were manageable, but are now no longer tractable by the sheer scale of information. An AI-enabled workflow is essentially taking an existing process and re-engineering it to allow end users to better understand and integrate the outputs of AI capabilities and data at scale. A successful AI-enabled workflow will result in significant efficiencies in some part of that workflow, such that user adoption can be driven by better outcomes. As we engage with our end users through this human-machine T&E, we first measure the status quo, or the traditional workflow. We'll ask, what are the key outputs of the process? How fast can the user currently execute that process? How accurate are they? Next, we'll introduce our naive users to the new AI-enabled workflow, and then collect all those metrics all over again. One of our key partners in this experimentation has been the 18th Airborne Corps, with whom Maven has partnered since April of 2020. Using their Scarlet Dragon series of exercises, we're able to overlay our human and machine T&E with conditions approaching real world. What we found is that when processes are re-engineered to consider the volume and speed of AI outputs, we see significant gains in performance. In one workflow that we re-engineered to integrate our AI-generated geospatial object detections, users identified on average 4 times more objects of interest, 20% more accurate in their observations, and were able to review 40% more imagery. But besides understanding the efficiencies we can gain through introducing AI into user workflows, we also want to understand how humans react to and view the outputs that they are using. While AI and automation are designed, in theory, to alleviate information burden on a human, both the volume and complexity of AI outputs may tax them in unexpected ways. One interesting reaction that we've seen during some of our tabletop exercises relates to how our user perceives the output of AI. Or the accuracy of that AI. We gave users perfect AI outputs, which were really human-validated objects. But they didn't know that. We told them they were AI-generated. And what we saw was that users continue to rate their perception of the machine's accuracy lower than the actual accuracy, which we knew was 100%. So we're still looking and conducting experimentation to better understand why this might be. But some of the areas that we're thinking of are users rating themselves as more expert than the machine? Did they perhaps have an underlying distrust of the AI? Or maybe did they misunderstand the ontology? The difference between a tank and a plane is really quite obvious, but the difference between a surface combat vessel and an amphibious assault vessel is not. Knowing that one is the parent class of another might affect whether an analyst would consider that detection to be incorrect. Another example where volume and complexity may affect how the user perceives AI is cognitive burden. At what point are we accelerating the rate at which users are provided AI outputs such that they begin to experience a decline in the quality of their output or their accuracy? Providing the data to make 1,000 decisions in an hour may be feasible with AI, but a human still faces a cognitive burden in making those 1,000 decisions. Well, a great deal of our human and machine T&E is currently based on quantitative experimentation. As we look to the future, NJ Maven will also be able to and hopes to track and measure users in real time. We want to use modern user-derived metrics to quantify activity in our platform, and we want it to be automated with minimal human intervention. If you recall, I mentioned earlier that a user's requirements and their activity within the system may not necessarily be aligned. By using automated user behavior metrics, we can identify where that may be occurring. For example, we may receive an official requirement to provide access to 100 users to our platform. But through automated monitoring, we see that really only 30% or so, or 30 or so people are using that environment. And then we can dig deeper and see that actually, of those 30 users, there's really only a handful that are dedicated power users. Understanding the difference between what people think they need and what their behavior suggests allow us to make better informed resource decisions about where we should allocate scarce resources. Building automated user behavior metrics into your AI system also allows you to take the principles of responsible AI throughout the AI system. From a national security perspective, this is even more important when one considers the potential use of AI from a warfighter perspective. Individual responsibility is certainly the first line of defense against unethical application of AI, but building it into your AI system makes it persistent and transparent and traceable throughout the entirety of that development lifecycle. It makes it easy to understand where users may be engaging in behavior inconsistent with the principles of ethical AI. In conclusion, human and machine teaming is made more effective with human-machine test and evaluation. Integration and deployment of AI systems at scale requires us to rethink approaches to how we build, buy, and manage technology within DoD. At Maven, process reengineering to take advantage of AI is not just something that we supply to our end users, it's also something we seek to implement within our own program. I'll close with a thank you to our end users, our partners in both government and industry. Our field-to-learn approach is built upon close partnership with all of those individuals throughout the entirety of our development cycle, and we would not be able to accomplish any of what we have without your avid and excited participation. So my thanks and gratitude for your support throughout the years.
Thank you so much, Rachael. That was an absolutely terrific start. And as we hear these different discussions, the ideas of test and evaluation, and the continued discussion of trust in these new AI systems is going to be pivotal as this technology continues over the years to further develop. Next, we're going to hear from Maggie Smith with the NSP Emerging Technologies Director from Accenture Federal Services. Maggie, the floor is yours.
All right, morning everyone. Thank you for this exciting opportunity. It's been a wonderful day so far. Today I'm going to talk about our experience implementing generative AI in one of our Accenture capabilities called the Next Gen Mission Analytics Platform, or NMA for short. First, I'm going to explain what NMA is. I'm not here to talk about that, but you have to know what it is for this to make sense. So NMA is an analyst tool for exploring and analyzing large-scale text data sets, primarily media. It collects and integrates disparate data sets, enriches them via a variety of processes, rules-based machine learning and human, and delivers this data in a self-service portal for query visualization and reporting. When I first saw the theme of this talk as human-machine teaming, It's the asset that immediately came to mind. NMA started as a capability over 10 years ago to enable human data labeling. So it provides tools for data annotation to help clients implement their key topics on media data. It's evolved over time to include AI/ML for enrichment, including both out-of-the-box cognitive services like language translation and bespoke models that we train on emissions taxonomy. Traditional ML has helped accelerate and automate processes, but we've maintained human effort, significant human effort, for data coding and quality assurance. I'm here to talk about LLMs, though. So with the launch of GPT-3, we rushed to make a splash with LLMs and test them out in NMA. So using Azure OpenAI, largely GPT 3.5 Turbo, we started with what I'll call like user-facing features, or honestly more like vanity features. And of course, we built a chat bot. Okay, so very original. Out of the gate, went for a chat box. We even gave it a very original name. We called it NMA Chatbot. But kind of wanted to get fast to market with it and do something with GPT. So the first LLM we trained was designed to generate complex Boolean queries. This sought to solve the challenge of an analyst approaching a new AOR or event. Instead of spending hours researching key terms and developing a comprehensive search string, analysts could prompt the model with key parameters, and it generates queries in seconds. Our first experience with LLMs was surprisingly approachable. We got pretty good results quickly. Although I have to mention that our first iteration, one of our models, our LLMs, actually told some limericks. So that was kind of an interesting outcome. Some what I'll call saucy limericks, I don't know. But it was pretty quickly resolved, and now it's a good cocktail party story. So we added some guardrails. We helped focus the LLM on our analyst use cases, and then also on our analytic and reporting style, so kind of using our corpus of existing reporting as well as just user experience on that reporting, and it pretty quickly resolved these. That said, we miss our little poet friend. We talk about him from time to time. The other use case we tackled was summarization, so transforming large collections of media into concise summaries, again in our reporting and analytics style. This was another super simple LLM feature. We gave it another original name, NMA Clips. Pretty much worked out of the box. But the challenge here was generating trust in the content. How would it even be useful without sources to back it up? To help mitigate this challenge, we introduced two features. The first was risk scoring to flag generated content that drifts too far from extractive responses, and the intent there is to flag it for extra analyst review. The second thing we did was use of RAG, retrieval augmented generation, to ground responses in source documents. So essentially we used an inference model to suggest citations for the generated data, so an analyst could go back and reference where it came from, thereby keeping the human heavily in the loop, right, by arming them with tools to accelerate content validation and hopefully the adoption of LLM-generated summaries. So summarization and query building, awesome, nice to have, but where we see the most gains for LLMs with this NMA capability is on the enrichment process with the data. So essentially using it to label and annotate data, something that humans have always done for us. This is a little bit of a harder nut to crack. So essentially, LLMs are helping our machine learning engineers design models faster. We're able to design these models, perfect them faster. We've taken many goes with traditional machine learning and this process that honestly, the results weren't good enough. So today, we can kind of test and swiftly implement new data processing schemas with relatively minimal investment. So an example there of one we've implemented, something traditionally done by human coders, is extracting quotes from media articles. And not just extracting the quote, but attributing the quote to a speaker. So, Maggie Smith today talked about LLMs and generative AI. She said she named an original chatbot, for example. So that's essentially what the model performs. And this is a really cool capability for us because that quote detection and attribution can then feed additional statistical models. We can use that for forecasting or simulation of what an actor might say or do given a certain scenario or constraint. Based on Maggie Smith's speeches, we think she will insert some bad humor to make herself more comfortable. So this helps us kind of discern sentiment and temporal trends. And it's amazing because to date, we've always had humans doing this. That said, is it perfect yet? Definitely not. We are not ready to remove humans from the process. We found that the deviations in LLM result quality are subtle and very challenging to mitigate without some kind of extra human review. And that human review can't just be anyone off the street. It really needs to be a subject matter expert in our case, regional experts, linguists, media analysts, to go through the results and validate. So LLMs are helping us create a high volume of data, but small tweaks have kind of unintended consequences, and we still have to do a lot of work to separate wheat from chaff. So just some anecdotes on how we've used LLMs to date, very, very promising. In terms of the role of humans, as we see them as kind of augmented, not replaced at this point. We will continue to evolve LLM features in NMA, but we do expect human coders to shift from data annotation to AI feedback during model training, and then also a quality assurance role during model deployment. So, the humans still need to be in the loop, but their role is going to change slightly in terms of that model development and implementation process. And today, even just with this short time, about a year working with these capabilities, we've been able to build and deploy more models, but it has to be hand in hand with SMEs to get it right. So I'll end with some overall observations and lessons learned. So what we've learned from this, we've learned that media environments are even bigger and more complex than we thought. And honestly, we thought we knew everything about media. This team's been doing this for over 10 years, like I mentioned. But LLMs have helped us dig deeper and observe more nuance in this fast-moving and ever-changing data set. LLMs are not the solution to everything. They've given us more data, made our processes faster, lowered the barrier to entry, but they can't be the only tool. Humans are essential, so I just have to say it. But we need smart, responsible people steering use of LLMs. You can't just layer LLMs on LLMs and call it a solution. And even though I think we're a bit guilty of that ourselves, but the human needs to be there. Our aspiration is LLM rapid prototyping, iteration, and refinement. We're working on the ability to deploy and develop accurate, targeted LLM-based classifiers during the course of a single news cycle. So, LLMs have helped us pivot quickly to new AORs or events, but what if there's something real-time happening within 48 hours, 24 hours, 12 hours? Can we build and rapidly deploy a highly accurate classifier during that news cycle? And I also have lots to say about cost and scale, but that's a different, and in my opinion, less exciting talk. So if anyone wants to talk about that. So it feels right to end on a quote from the father of media studies, Marshall McLuhan, who you may or may not be familiar with. But he said, "We shape our tools, and then our tools shape us." So I think we have an idea of where LLMs are going and how they're changing analyst behavior, but I think a lot of this is going to be very subtle and over time, right? We've all started using LMs and GPT in our personal life. It's kind of rewiring the way we think and the way we work with these tools. When we go to design these tools, we can certainly think through these things, but I think a lot of the downstream effects are going to be kind of unintended and more natural. So thank you for the opportunity.
Thank you again, Maggie. It's an incredibly important topic as industry and government and then even academia are continuing to try to understand and learn how analysts and humans are going to continue to use LLMs within their work and just making their lives more efficient and easier. So thank you for that. Next up, we have someone I've known for some time now here in DC, the former Chief Digital Transformation Officer of the United States Air Force, Stuart Wagner. He's going to take us into a little bit of a lighter topic, learning and adapting during competition and war. So, Stuart, if you want to come on up. Thanks. The floor is yours.
All right, I'm putting myself on the clock. I'm going to try to encapsulate, it just finished 2 weeks ago at the Air Force. I'm going to try to encapsulate what I learned over the past 3 years in my term in the Air Force. A little bit about me, former Microsoft software developer who came here to the DoD on civic leave, had previously focused on telemetry data, which I'll talk a bit about. Automatically collected data off operational systems. Went to Advana and ran development and engineering there at OSD. Started a program called Game Changer, actually, that's done some work with DIA, which was focused on policy analytics, basically created a search engine and a crawler for the DoD for policy. And my last role was with the Air Force. This talk is about learning and adapting live during war, which is what we've spent the past 3 years trying to prototype and learn about. If some estimates are correct that we might be at war in the next 3 to 5 years, we will go to war with largely what we have today. This means we will influence many of those capabilities largely through adaptation. This is already happening in EUCOM and in CENTCOM. We suspect adaptations during war provide compounding benefits over time and can significantly influence the outcome of them. What we spent our time thinking about is how big tech, starting from where I came from, how does big tech learn and adapt, all right, using data? They rely on something called telemetry, which is automatically collected data. A common refrain that's said in DoD to target the engineers to come to, government is leave your job focused on advertisements, right, working on ad tech. Leave your job and come work on real mission, right? But what I think a lot of people don't think about is why so many engineers work on ad tech. And the reason for that is because they're constantly calibrating and changing the advertisements to be most effective. They spend most of their time developing calibrations and small dials, which influence revenue and profit by small percentages. And so this is kind of the context which how can you apply that? How can you do that during war, was what we tried to ask. If you look across industry, Microsoft focuses, what I worked on actually was health of systems. They use and learn from data. But even the Facebook news feed is built off of and undergirded with telemetry. Google's PageRank and search, again, undergirded and trained with telemetry. A Tesla, is trained with automatically collected data. And Starlink and resilient communications are actually established through the use of telemetry and software updates as well. This isn't only the case for American companies. Dahua, TikTok, Baidu, every big tech company in the world undergirds with automatically collected data. My first assertion today is that these companies exist because they were able to learn and adapt faster than their competitors based on the automatic collection of data. A comparable vignette, if you will, would be the night after scenario in the Department of Defense. You can think of the night after being the night after the start of a conflict kicking off. And the question that many commanders would be faced with was how could they learn, how could they take what they learned from the past 24 hours and use it to learn and adapt to fight better tomorrow, right? Is it possible to update a weapons system or tactics like Facebook updates and newsfeed, SpaceX updates, Starlink? Starting with the IC, there are 17 IC organizations that are focused on red data to avoid technical and tactical surprise. I suspect many or all of them are in this room today. But to adapt the DoD systems, we need blue data, the data from DoD systems. Who manages learning and adapting from blue data at the DoD today? My second assertion is nobody. This is a gap, in my opinion. So when I entered my prior role in the Air Force, I asked where the most interesting blue telemetry data was located. Bits off jets, bits off ships, bits off subs, bits off spacecraft, right? General Slife, the current vice chief, recently described this problem. We record the data off the jets and what we call tapes, because they used to be tapes, now hard drives. And if there isn't an incident, we put the data in a safe, and we typically don't review it or watch it. And we wait for the next flight to record over it. These data are the quintessential elements to developing JADC2. But in many cases, the DoD treats this operational data like the trash I took out last week. The reasons for this are immense. The cost of storing the classified data is on the programs. The manual effort to capture the data is immense. The digital pipes in our combatant commands are too small, and the physical piping, the actual carrying of the data, is highly bureaucratic. I didn't have the resources to fix this problem myself. So instead, I sought to evangelize the problem and the benefits of solving it to build momentum to store and leverage data like big tech. So we started a hackathon series to learn and adapt from the blue data. Hackathons, not to be confused with cyber hacking, have a weird techie vibe that emphasizes unusual, novel, emergent software development or hardware development, often while working long hours on Red Bull and Doritos for bragging rights, right? We ran these at 9 locations, 3 security classifications, and had around 2,000 participants. Use cases were supplied by organizations, DoD organizations, federal organizations that paid TDY to send their people to represent a problem. Anybody could work on any problem they desired if it didn't break a law. The makeup was about 65% DoD employees on average and 35% industry, American citizens, and contractors. And yes, any American citizen was eligible to participate. Our events produced a need to know and access them to CUI data. The vibe at our events was strong. Military members who couldn't get approval to travel took leave and paid their own way. It's happened at every event. American engineers with no security clearance, sometimes fresh off of selling their companies, began paying their own way to attend. And many different DoD organizations possessing software and data began sponsoring these events or participating in bringing their own capabilities, such as Advana, TOC, AFRL, SOCOM, Stitches, and many others within DoD. So this became an opportunity to experiment and learn about how people could use your software that had been developed. We built nearly 200 prototypes from operational data at a total cost of around 2 SBIR2s, representing an approximate blended cost of $25,000 per prototype from operational data. This is an 80x improvement in cost per prototype over SBIR2s. We saw around 20 to 30% of the project's produce effects get consumed by existing programs, create new programs, or change enterprise planning. And we excited a base of technical DoD employees in the defense industrial base. The Facebook like button actually was invented at a hackathon. Companies have been created at hackathons, and I can now say major defense programs have adopted projects from hackathons. We learned from these events there are 4 ways you can learn and adapt from data. 1, and I'm seeing time now, I'm looking like I'm going to get pushed up soon, so I'll be quick. There are 4 ways you learn and adapt from data. 1, you adapt a weapon system. 2, you adapt the way you use the weapon system. That's tactics, techniques, and procedures. 3, you adapt the strategy. Or 4, you adapt the way you train and exercise with these data. Okay. I'll talk about 2 things last. The first is what we call the bits to effect cycle. So what did we learn from this? How does one actually go about adapting during war? We think ultimately what you're trying to do is go from the creation of data to an effect. And so there's a series of steps one must go through. But if you can expedite that time to effect, you can learn and adapt faster than an adversary. Okay, I'll describe a couple stories real quick from the hackathons. I met some pilots at our first event who ended up creating a post-flight visualization tool for a major defense weapons system, which was pretty awesome. We had some engineers at our second event predict space launch scrubs at a rate that exceeded basically the 3 days of data that had been stored by the organization. And so they went and crawled, produced their own capability, it outpredicted. I watched a team at INDOPACOM train an LLM model on prior exercise data and then use that model during that week to discover live problems during the exercise. And there's many more. It's just too many to talk about when you have 200. As you may have heard, my term recently came to an end, and it turns out Congress never told the DoD to run hackathons, so they didn't put it in the NDAA, and so we're working on that now. As for what I'd like to do next, I'm looking to find federal organizations that would like to participate and partner in continuing this work. Thanks, Bishop. I appreciate it.
And thank you again, Stuart. What I heard, at least in some part of this, is there's a critical telemetry gap that perhaps industry and government can work together on to close. And that's, again, another opportunity for that type of collaboration. To close out our session, next we're going to have our final speaker, Mr. Taxson, who is the chief of CLOUDworks at the CIA, and he will be here to discuss the foundation for a digital evolution.
Thanks, Bishop. All right, can you hear me? All right, so I'm preventing you from lunch. That's what I hear, right? All right, so I'll make this quick. So at the Central Intelligence Agency, and specifically in the Directorate of Digital Innovation, or DDI, we believe that human-machine teaming will produce smart feedback loops, which will allow us to do analysis on all-source intelligence to get insights at scale, speed, and quality that we haven't been able to get before. We want to smash traditional timelines, and we want to be able to yield real-time, on-demand results at scale and great magnitude. So all of this, with human-machine teaming and really AI, this is our North Star. And we believe that it will unlock possibilities that humans and machines couldn't do by themselves, all right? So AI is not new to CIA. We've actually been leveraging it for many years. In our analyst cadre, we've used like narrow AI, like machine learning, to do categorization and classification of data. But advances in Gen AI, like image generators or LLMs, right, just becomes another tool in our toolkit. And we want to use those tools to help us adjust and maybe increase the speed or improve the accuracy of our previous AI capabilities to support our intelligence work, right? So as we look at the future, right, so what's the future of the analyst in the world of Gen AI and human-machine teaming? We can look at those capabilities to do a variety of things. One would be a search and discovery aid, right? So this would allow our analysts to easily categorize information on specific topics or rapidly review reporting requirements on a narrow summarization task, which I haven't been able to do. We can use the fluency of LLMs to create ideation aids, right? Can it help us with brainstorming? Can it help us with scenario development or strategic analytic techniques, right? Next would be critical thinking aids, right? How do we challenge assumptions? How can we generate counter arguments in the things that we're doing? And then lastly, might want to use it for just aids in writing, right? So can we use an LLM to help our analysts do an initial draft of an assessment? Can we also use it to make sure that our analysts are adhering to strict writing guidelines, right? There's a lot of possibilities there that we can do. The way we deploy it, right, will come in a variety of different ways. You know, we can look at it from an enterprise capability, right? If all of our analysts are going to use a capability like leveraging natural language processing to do search queries against various corpuses of data in different dialects, right? That would be cool. Or we might have boutique types of applications of it. So maybe using a code generator or a co-pilot with our data scientists to look at a specific area or region of discovery, right? There's different ways to do that. But with any type of technology, and we've heard this a lot today, there do come concerns, right? So we are concerned about bias. We are concerned about uncertainty. We are concerned about hallucinations. So just like everybody else, we heard on previous panels, we're conducting various use cases and tests to make sure that we can mitigate these concerns if we implement this technology. Now, at the end of the day, we do believe that human and machine teaming will increase the rigor and speed of our assessments as we move forward. AI will be a partner to our analysts. However, human judgment will always be at the core of our analytic assessments. So we haven't taken that full leap yet. So this is great, right? We're talking about the future and the capabilities and what we're going to try to do. But I think we heard this a little earlier. How are we actually going to get these capabilities? How are we going to deploy these across our different classification domains? So that's where we come in. So I have the privilege of leading a group at CIA called CLOUDworks. And we reside within our Directorate of Digital Innovation, within the IT enterprise, within our technical services office. And our mission is to provide government on-prem hosting solutions along with commercial cloud capabilities. So we have the honor of serving as the IC's Service of Common Concern for the Commercial Cloud Enterprise C2E contract. And what that contract allows the IC to do is have access to modern cloud capabilities from great vendors, to include Amazon Web Services, Microsoft Azure, IBM, Google, and Oracle. And we're working very closely with all of these providers to get a better understanding of these new Gen AI capabilities. You can go to any of their conferences, and that's what you hear all the time. So we're trying to figure out how do we bring those into the community, and how do we deploy those within our classified regions, right? That's a big step, right? We need to figure out how to give you all access to those capabilities. We're also partnering with our community stakeholders. So at CIA, Lakshmi Raman is our head of AI, right? It's our AI executive. So working very closely with her to understand capabilities and techniques, but also our other partners across the community. Because we really want to understand what you're trying to do. This is a real interesting area now, because it's not like previous technologies where you sort of might know what you're doing. We sort of need something in to figure it out, right? We need a baby step crawl. We heard that earlier. But what we're trying to look at is, within CLOUDworks, is how do we deploy this out, right? So I talked about the cloud, but we also own hosting, and data centers. So we're also looking at hybrid solutions. So if I want to leave my data in my data centers because it's either sensitive or it's too expensive to store in the cloud, how can I bring these AI capabilities into our data centers so you can take advantage of them? We're also starting to look at edge, right? We can't forget edge. How do I run LLMs at the edge, right? How do I run inference models? Because we're going to do that. We need to do that to, one, support the warfighter, two, to support collection analysis in the field, right? So we're going to have to think about all of that. So at CLOUDworks, our vision is to be the foundation for digital evolution. And the reason for that is that we believe that all mission systems going forward will be built on the foundation of our hosting, whether it's in commercial cloud, on-prem, hybrid, right? There'll be some variance of that. But we chose the word evolution specifically and not transformation. Transformation has a beginning and an end. I believe in our community, we're going to constantly be evolving, especially when it comes to human and machine teaming and AI. And we're going to need to evolve in order to outpace our adversaries. So with that, thank you.